A very good morning to everyone. I am Anand Krishna Sharma, lecturer electronics at Government Polytechnic College Bikaner. Today in this video lecture of electronic component and shop practice, I will discuss about the construction of IFT. In this video lecture, I will cover the basic theory of IFT, construction of IFT, and working of IFT. So let's start with the basic theory of IFT. IFT is known as the intermediate frequency transformer. So the basic of the transformer and a tank circuit is the basic of the IFT. We all know that the transformer is a passive electric circuit which is used to transfer electric energy from one circuit to another circuit. Both the circuits are physically separated. When the primary coil or a primary of the first circuit is excited via the alternating current source, the flux linkage to the secondary or another coil produce the EMF at the secondary. It is known as the mutual inductance or the Faraday law. In the tank circuit, L and C are connected together. When they are excited to an alternating current source, only the signal at a resonant frequency will oscillate and all other frequencies are rejected. So we combine the basic of the tank circuit and transformer, we will get the IFT. So IFT is a two parallel tune circuit placed together so that they will pass the energy only particular limited range of frequency, all other frequency are rejected. In a radio receiver or superheterodyne receiver, the input signal is translated to the intermediate frequency via a mixer. The intermediate frequency is sent to the intermediate frequency amplifier. Before it's sent to the amplifier, it is passed through the IFT or intermediate frequency transformer, which provide the selectivity. It is a basic construction of IFT. Here on the right side we have a top view of the IFT. On the left side we have a side view of the IFT. In the top view we can see the two capacitor. On the side view we have a secondary coil and the primary coil. Secondary coil have a higher number of the turns, so it's step up the voltage at the intermediate frequency. Let's start the working of the IFT. Here the primary circuit or primary winding of the IFT is excited via a number of frequency, so it will start oscillating at a particular tune frequency that is known as the IF frequency. The flux linkage to the frequency is also linked to the secondary winding, and secondary winding produce the voltage that is only at a limited range of frequency or a particular intermediate frequency for the depending the value of the Q. We already discussed that the number of the turn are higher in the secondary, so it's step up the voltage at the intermediate frequency. It is market available. The it's have a shielded, it have two IF transform as shown in the figure that are shielded in the aluminum box. If we remove the aluminum box, we will see that two type of the transformer. Here two IF transformer, one is the AM-IF and the FM-IF for the radio. Here the primary and secondary of the upper transformer and primary and secondary of the lower IF transformer can be seen in the picture. In this picture the capacitor is fixed but the inductance is a variable. Here via the moving of the coil, moving of the core, we can change the value of the inductance. Here we have the four core for the primary and secondary of the first IFT and primary and secondary of the second IFT. If we change the position of the core, the value of the inductance will be varied, and the resonant frequency of the crank circuit will be vary accordingly. In the previous circuit, we have used the trimmer capacitor and the constant inductor. So by the varying of the value of the capacitor, the resonant frequency can be varied. Here we can see that there is a distance between the primary and the secondary. Normally capacitor, the primary and secondary are close together, so they have a tight coupling, very high value of the K. But here the we can see that the a large distance between the primary and secondary. It is due to the reason that if we they are close together, then they have a capacitive coupling, and a large number of frequency will be transferred from one circuit to another circuit, which is undesirable. So we can see there is a distance between the primary and the secondary of the IFT. Thank you very much.